Okay, so we have been presented with this problem. If you analyze this problem, the left term of every term is increasing in a GP and the right term of every term is increasing in an AP. So this type of a sequence is called as an AGP, arithmetic or geometric progression. You can search about that on the internet. But the method to solve this sequence is pretty much simple. Whenever you are asked to find the summation of an AGP, just follow the method I'm going to show you now. In fact, you can give it a try. It's not very difficult, and you have seen the method before. So go for it. Okay, I hope you're back. So I'll write s, actually I'll rewrite s as it is just to make the process a bit clear. So I'll just write 3 squared into 7 very quickly. Add it up to 3 raised to n into 5 plus n minus 1 into d, and d here is nothing else but 2, the common difference. Now I'm going to rewrite s, but instead of writing it just below it, I'm going to write 3 into 5 here plus 3 into 3 squared into 7 here, that's a squared here. I'll just write this term as well just to ensure clarity. Okay, same thing, and the last term here would be 3 raised to n plus 5 plus n minus 1 into d. Okay, now there's a standard trick here. You just multiply by r the second equation, so this becomes a 3 squared, r which is 3 in this case, so it would be 3. So r square, and now it is 3 cube here. Here it becomes n plus 1 and so on. The advantage of doing this thing is when you subtract this equation from this equation, you get s 1 minus 3 is equal to, I'll write this term as it is, so it's 3 into 5 plus, I'm going to factor out a 3 square, and this will become 7 minus 5, which is nothing else but 2, and I'm going to factor out a 3 cube here, so this term will become 9 minus 7, which is nothing else but 2, and you'll see 3 to the 4 plus 3 to the 4 into 2, and so on up to 3 to the nth power into 2, and this term will remain as it is because the first term didn't pair with anything, so this term won't pair with anything else. So 3 to the n plus 1 actually, 5 plus n minus 1 into d. D is 2, I always forget to write this 2 here. Okay, cool enough. So minus 2s, right, minus 2 is 3 into 5 minus 3 raised to n plus 1 plus 5 plus n minus 1 into 2, and now I'm going to factor out a 2 from this thing, so 2 into 3 squared actually, plus 3 cube, and so on up to 3 raised to n. So now you see a GP forming. How interesting is that? And it gives you a feeling that the problem is actually solved. So there's nothing more to it, it's just minus 2s, 3 into 5 minus 3 raised to n plus 1 plus 5 plus n minus 1 into 2 plus 2, and this is a GP, so the first term is 3 squared, the common ratio is r, n minus 1, I'm just using the formula for a GP, upon 3 minus 1. Now just divide by 2 on both sides, divide by minus 2 actually, so this will become minus 2, and the whole thing really will be divided by minus 2. And for me this is the answer. You could go ahead and simplify it, but you get the general method. This was the main key catch. Okay, so in this problem we have been given the sum of 3 terms a, b and c as 1, and we have been asked to find the maximum value of a, b cube, c squared. So let me explain this in detail. Okay, so you have been asked to find the maximum value and you have been given the sum. This strongly suggests to me that you have to use the Amgm inequality. Am is greater than or equal to Gm. By the way, the Amgm inequality says that the average, or a plus b by 2, I'll write it in symbolic form, is greater than or equal to square root of ab. Okay, so how we can apply this in this sum? I'll just apply the Amgm inequality without any manipulation of terms. So a plus b plus c by 3 should be greater than or equal to ABC raised to 1/3. What is a plus b plus c? It's just 1. So 1/3 is greater than or equal to ABC raised to 1/3. Now if cubing on both sides, ABC is less than or equal to 1 upon 27. So what does this mean? On a number line, there is somewhere 1 upon 27 and ABC is less than it. It is always lesser than it or it is equal to it. So it means that the maximum value of ABC is 1 upon 27. Let us use this concept to solve this sum. Okay, I've made some space for this problem. So I want to get the indices as 3 and 2. So I can legally split b as b by 3 plus b by 3 plus b by 3. The reason I'll do it because when I multiply these three terms together, I'll get a b cube factor. Similarly, I can split c as c by 2 plus c by 2, and that just remains c. So applying Amgm inequality, I get a plus b by 3 plus b by 3 plus b by 3 plus c by 2 plus c by 2 is greater than or equal to a, and now I'm going to multiply these three terms, so it will become b cube upon 27 into, and multiplying these terms, c square upon 4, the whole raised to, what will it be? How many terms are there? 1, 2, 3, 4, 5, 6. The whole raised to 6. Alright. And this will be upon 6, of course. So a b cube c square upon 27 times 4, the whole raised to 6, would be less than or equal to, what is ABC, right? This is just A, this is just B, this is just C. So A plus B plus C is 1. So I'll write 1 there and I'll divide it by 6, writing this 6 as it is. Now I have to raise both sides to the 6th power. This is 1/6. I'm actually confusing myself. So AB cube C square upon 27 times 4 should be less than or equal to 1 upon 6 raised to 6. I'll write it here, and just, I'm not doing the calculations now, you can do it. 27 times 4 upon 6 raised to 6. So this is my final answer. Now you could leave this as it is, there's no harm in it. The main thing was to illustrate the method to solve these kind of problems. Hope you benefited from our videos. Be sure to subscribe to our channel, and thank you for joining us. It's been a great pleasure.